Algebra 2 Honors 4.2a notes. You're going to be adding and subtracting and multiplying polynomials. When you do these problems, you need to make sure that you copy the original problems down on your paper first, work down the page, and use extra columns as necessary. So anyway, so in number 1, we're going to add these two in what they call the vertical format. So copy the first one down, right below it, line up your like terms. Draw a line to indicate you're going to do addition or subtraction, and then just add the like terms. 3x cubed plus 8x squared minus 3x and plus 2. And then box or circle your final answer. And so then it says add in a horizontal format. You're just going to list the first polynomial and add to that the second. And then go down the page on the next line, write an equals, and then collect your like terms. 2y squared plus y squared is 3y squared. A minus 1y minus 6y is a minus 7y. And 2 and 9 is plus 11. And then we're going to subtract. And it's to subtract this first polynomial from the second. So that means we're going to start with the second and subtract that first polynomial from it. So minus, and I'm going to just put that second one in parentheses. And then draw a line to indicate where we're adding or subtracting. And when you subtract, what I like to do is add the opposite. And so I'm going to just change this to addition and go in and change all of the signs on each of those. And adding the opposite, I get a 2x cubed minus 9x squared minus 3x minus 7. Excuse me. Oops. Minus 3 plus 1 is minus 2x. All right. So, and there's my answer to that. So then in example 4, subtract this first polynomial from the second. So we're going to put the second polynomial in front and then write it with minus and in parentheses. And then on a line below it, put an equals and then show distributing the negative. And so oftentimes people will forget to change the signs on those two and then collect like terms. So we have a 2z squared, a minus 3z, and minus 3. So there's some addition and subtraction. Now we're going to multiply in a vertical format. And so I'm going to put that first polynomial at top and the x minus 2 below it. And this goes a little different than when you multiply numbers like 358 times 42. We do this a little differently. I start with the x, and I'm going to multiply all three of those terms by the x. That's how I'm going to start. And so I'm going to write that on the first line below the bar. Get a 2x cubed minus 3x squared plus 5x. And then I'm going to not use the x anymore. I am going to take the negative 2 times all three of those, and I'm going to put that in the second row, and I'm going to anticipate like terms and write them underneath the like terms as I multiply, which means if I take a negative 2 times 2x squared, I have a minus 4x squared, so I'm going to line that up with the like terms so that when I add them, they're together. Then take negative 2 times negative 3x, and I get plus 6x. I'm going to line that up right with the x because those are going to be like terms. And when I take negative 2 times 5, excuse me, that's a negative 10, and there are no constants in the first row, so I'm just going to start another column. And then everything's lined up to add. And so there we have the product. So lining things up neatly, having the original problem there, and then that's multiplying them. Okay, then we have where we're multiplying 3. We have x plus 2 times x minus 1 times x minus 3. And so what you're going to do is start by multiplying 2 together. And then after you get that product, distribute each of the terms of the binomial across and add like terms. So start by writing the original problem, and then hopefully you can just multiply these right away. You get a minus 1x and a plus 2x, which is plus x, and a minus 2. If you need to do one step where you show all 4 terms, that's fine. And then when I'm doing this in the horizontal, I'm basically just going to distribute this x to each term and multiply it. And so I get an x cubed plus x squared minus 2x. And then after I've distributed that x times each of them, then I'm going to take the negative 3 times each of those. Make sure it's a minus 3 times x squared, minus 3x squared. Then you get a minus 3x and a plus 6. And then add like terms. So we have an x cubed. We have an x squared minus 3x squared is a minus 2x squared. Minus 2x minus 3x is a minus 5x. And then plus 6. Notice the equal signs. I'm working down. Each of these goes on its own line. You work down the page. And then box circle your final answer. All right, and then example 7, prove that this polynomial, the identity for the square of a binomial. All I'm asking you to do is take a minus b times a minus b and show that it comes out to a squared minus 2ab plus b squared, which means I'm going to distribute the a across, then distribute the minus b across. So adding like terms, these are like terms. There are 2 of those. And notice that we got what was on the right side. So that checks. So the whole thing is, it's a special product. And so that special product is right there, a minus b quantity squared, a squared minus 2ab plus b squared. I've been saying square it, multiply, and double it. And so anyway, there you have it. So in example 8, use the square of the binomial to calculate 24 squared. And this is just something that I like to do because sometimes it's just easier. It's kind of fun to do the mental math. We can write 24 as 20 plus 4 squared. And then squaring, so you've got that a term squared. And in this case, instead of plus, we're going to, or minus, we'll use plus. Because if this is a minus b squared, this is a plus b squared is a squared plus 2ab plus b squared. And so then we're going to get a 2 and then your a times your b, and then plus your b squared. So you get 400 plus 160 plus 16. So that is going to be 576. Now we could have also done 24 squared by using 25 minus 1 or 30 minus 6. And we would have had the square it, multiply and double, and square, and that would have also come to 576. So just something to think about. So that's expanding. When you have a square of a binomial, you get a trinomial. But we also have another special product of sums and difference where one is negative and one is positive. This is different because when that happens, you just get 2 terms, and that's the difference of the squares. And so applying that, we notice in part A, we have a 2x minus 7 and 2x plus 7. So the A's are the same, the B's are the same, but one's positive, one's negative. That means this will multiply into 2x squared minus 7 squared. It's because the middle two terms always are opposite and they cancel. And so 2x squared is 4x squared, and we have a minus 49. Notice you write the original problem, you go down to the next line, put an equals, and then write the quantity 2x squared minus 7 squared, and then down a line equals, and then multiply it out and box or circle your final answer. And then we have this 4y plus 3 squared. So write the original problem, go down a line, put the 4y with the square there, but this is not the same. This one is not a sum and a difference. It's this right here where we have that a plus b quantity squared. So we get that plus 2 times 4y times 3. Remember, multiply and double to get the middle. And then the last term squared. The square of a binomial is a trinomial. And you get 16y squared plus 24y plus 9. Square it, multiply and double it. And then I just want to mention one other kind of problem. I think you have something where you have a box and maybe they say the height is 5x, maybe this is x plus 4, and maybe this is 2x plus 3 or something. They give you the dimensions of a rectangular box and they want the volume written as a polynomial. And that volume is just going to be the product of all three of those sides, because volume is length times width times height for a rectangular box. And so in this case, I would multiply the binomials, getting a 2x squared. We have a 3 and an 8, so an 11x plus 12. And then distribute, getting 10x cubed plus 55x squared, and then plus 60x, and there would be your volume written out as a polynomial. So if you see something like that, that's what we're looking at, and I think that's it.